So let's go ahead and begin with the trapezoid rule. And this problem has the trapezoid rule. So we have two more rules we got to learn. Left and right we learned about, very similar. Trapezoid rule is really simple because just the left plus the right divided by 2. It's just averaging the two. You find the left sum, right sum, and divided by 2. And many of you probably already thought about it. Like, hey, why can't we just find both sums? If one's over, one's under, let's just find them both and average it. And guess what? If you do that, that gives you what's called the trapezoid rule. And technically what's going on, if you have a curve, and if you remember as we drew our rectangles, from the 2 points, we're connecting the points, and that's creating trapezoids. And that's technically what's going on if you really look into the formula. But it just so happened that it actually is just the average of the left and the right rule, which is really makes computations really easy for us. So we're going to do 3 subdivisions here. So we're going from -2 to 4, and we need 3 subdivisions. So we have our first subdivision here, our next one here, and our next one here. And so what we're actually finding is this. We're finding these trapezoids. We're going to find the area of those trapezoids. And this one's actually more of a triangle, right? But it'll still fit the formula. Wait, can't draw this right. So let's go ahead and make our table, do a left sum and a right sum, and use that to evaluate. So for -2, when x is -2, our y is 0. When x is 0, our y was 4. And when x was 2, our y is 6. And when x is 4, our y is 4. So for our left sum, it's going to be 2 times 0 plus 2 times 4 plus 2 times 6, which is 8 plus 12, which is 20. Then for our right sum, it's going to be 2 times 4 plus 2 times 6 plus 2 times 4. So that's going to be 8 plus 12 again is 20 plus another 8. So this is 28. So we'll average the two. So our trapezoid is going to be 20 plus 28 divided by 2. Just the average of the two. 48 divided by 2 is 24. It makes sense. It's the number right in between the two of them. It's going to be 24. And the T of 3 is just saying 3 rectangles. That's what that 3 means. So anyways, just to recap, we found the left sum, the right sum. Use the table. Put our graph into a table. Makes it easy. We understand tables. And then average the two sums. Geometrically, this is what's going on. That's the area we found, which looks to be like a slight under approximation. And the way we actually tell if it's an over or under, which we don't have to do, is the second derivative, though. There is a way to tell, and it's using the second derivative. Okay, so that's the trapezoid. Now midpoint's a little more of a pain. Trapezoid's simple. Do what you did before. Find the left sum, find the right sum. The formula looks horrendous. It looks really bad. But if you just follow this rule, it makes it way easier. The midpoint, though, is not as much fun. So the way midpoint works is we're going to do 3 equal subdivisions. So that's going to be, this will be our first subdivision. That's our first base. This is our second and third. So we have 1, 2, 3 rectangles. And we're going to actually use the middle y value. So those are going to be our heights. We're using the middle. So notice I broke it into 3 equal pieces. I broke the x, the domain there, in 3 equal pieces. But what are we using for the y value? We're using the middle, and that's why it's called the midpoint. So how do we make our table? That's when it gets a bit interesting. So let's go ahead and make our table. So normally the x values that we use is 0.5.
Attention, Hopewell High School, custodian Richie, would you please report to the front office?
1.5.
Richie, please report to the front office. Thank you, and flat on for Hopewell.
2.5. If you see here, I'm leaving a space for a reason. And then 3.5. So our bases of the rectangle are going to be their distances, which is 1. But what do we use for the y values? We're going to use the y value that's in between these. So that's not always necessarily available like on this table. So we kind of have to put ourselves into a special situation and kind of, skip that spot and figure out, okay, what's the x value in between? It would be 1, and the y value there was 3. The next x value is 2, and the y value there is 1. The next x value is 3, and the y value there is 2. So our base of our rectangles are each 1, but we're going to be using 3, the 1, and the 2 as our y values. So kind of interesting, a little bit different. Here we're doing 3 equal subdivisions. They're always going to kind of leave it a little bit nicer where there's a number in the middle like that. But then we're going to use the y values like that are right in the middle of those two. So those would be the y values being used. So just be careful forming that table. Where it gets a little more difficult is when we have to do it with algebra. So midpoint using algebra. So we're going to do from 1 to 4 using 3 equal subdivisions. So our x values, if you want to find your delta x, there's actually a formula for it, and we're going to be looking into that. So n is our subdivision, so b is this would be our b, this would be our a, and this would be our n. So each base of the rectangle is 1. So if we were to draw our regular table, we would start with 1, then add 1 to get 2, then add 1 to get 3, then add 1 to get 4. That's what we normally do, but for midpoint, we're going to leave a gap. So each base of a rectangle, as we calculated earlier, is 1. But we got to come up with the y values. So right in between these is 1.5. Right in between here is 2.5. Right in between here is 3.5. So that's what we're going to be plugging in. Or actually, we should be using fractions for this. So that would be 3 halves. 1 plus 2 divided by 2 is 3 over 2. 2 plus 3 divided by 2, we're averaging those two. To get 5 over 2 would be this one. And then last, this would be 7 over 2. So if we plug them in, what's our function for this? Our function is x squared. To get 9 over 4. And then this one would be 25 over 4. And then this one would be 49 over 4, which is kind of nice because it looked like it was going to be crazy. But they all have the same denominator, so that's not too bad. And so from there, it's just 1 times that. So it's 9 over 4 plus 25 over 4 plus 49 over 4. And then 9 plus 25 plus 49. Is 83. And that would be our answer.